Hello everyone, and welcome to the lecture where we'll be going over the recursion homework example problems and the solutions. Here I'm at the Jupyter Notebooks, and if you go to the recursion folder, you'll notice a Jupyter Notebook called Recursion Homework Example Problems - Solutions. You can go ahead and click this notebook. It'll take you here to the solutions notebook, and you can go ahead and read through the solutions here on your own if you're interested in following along. Okay, I'll go ahead and live code the solutions and explain the thinking through them. So let's go ahead and start off with problem 1. So the first problem said, problem 1, write a recursive function which takes an integer and computes the cumulative sum of 0 to that integer. For example, if n equals 4, return the result of 4 plus 3 plus 2 plus 1 plus 0, which is 10. So how do we do this? First thing I want to consider is the base case. So in this case, if we write this recursively, we have n plus n minus 1 plus n minus 2 all the way to plus 0. So regardless how high the n is, we know it's going to go all the way down to 0. So our base case will be then if n is equal to 0. And what I'm going to return, in this case, is 0. Because once I hit 0, I don't want to add anything else to it. So this is our base case. After that, we have the recursive case, which in this case, what we're going to do is just return that n plus our recursive call in that function, recsum, on n minus 1. And we can go ahead and check this out if we want to, recsum on 4, and you'll note we get 10. All right, so go ahead and read through, make sure you really understand the solution here. The big factor here was the base case, recognizing it, knowing what to return, and then being able to transform this line of thinking, n plus n minus 1 plus n minus 2, into this line of code, return n plus the recursive call in the function on n minus 1. Hopefully this looked familiar to you because it's so similar to that factorial function we created earlier. All right, moving along, we have problem 2. Let's go ahead and make some more space in the cell. Given an integer, create a function which returns the sum of all the individual digits in that integer. For example, if n equals 4,321, return 4 plus 3 plus 2 plus 1. Okay. This one was a little trickier, and I gave you a couple hints. So let's think of what the base case is here. The base case will happen as we go along and use mod and division to take and strip these numbers each individually, will be when the remaining length of that n is just 1. So what I mean by that is if length of that digit, and you'll notice there's an error with this, which I'll fix in a second, is equal to 1, I just want to return that n. We won't have to strip off any more digits from it. And what we're going to be doing in the recursive case, else, is doing something here to basically strip another digit off of that. So the error that's going to happen here, if I don't fix it, is that since it's an integer, it actually doesn't have a length. So kind of a quick way, and thanks to Python, I can just cast it to a string and then take the length and make sure it's equal to 1. There's other ways to do this, but in this case, it's a pretty straightforward solution. So how can I strip another digit if I'm not at the base case? Let's go ahead and just comment that as the base case so it's clear. So I wrote about this in the hint, and what I can do is return n mod 10. That will be the number I want to add to the recursive call, which in this case will be sum underscore func and divided by 10. Note that I'm dividing by an integer here, and since this is Python 2, this will work correctly. You'll have to use the differences between classic division and true division. So this is going to perform classic division since I'm using Python 2 right now. If you're using Python 3, you'll have to make sure this is performing classic division, not actual true division, in order for this to work correctly and for you to strip these functions out. Okay, there's a note about that in the solution notebook. So moving along, we have the last problem. Now, as I mentioned, it's a more advanced problem than the previous two, has a lot of variation on possibilities, and we're going to go ahead and solve it a particular way. So let's go ahead and break it down. So we have this function, word underscore split. So what I'm going to do is have, in this case, 3 arguments. And note, the solution I'm going to implement here makes a lot of use of the Python language. Now, the first thing I'm going to do is check if output is none. I'm going to set output equal to an empty list. So the reason I just can't put in output as an empty list into the function here is because I'm going to call it recursively. And if I were to set it at the beginning as a default parameter, it would overwrite the output list that I want to put out every single time. So basically all this does here, if output is none, output equals empty list, is it just takes care of creating an empty list on the first instance of that recursion. So let's go ahead and think of what I want to do here. I want to say for word in list of words, so for every word in that list, for word in list of words, I'm just doing tab complete there. Then I want to think if the current phrase begins with the word, we have a split point. So remember what we're trying to do here. We want to create a function that takes in the string phrase and a set list of words, and then the function is going to then determine if it's possible to split the string in a way in which words can be made from the list of words. So what I'm doing here is I'm saying for every word in that list of words, if the current phrase begins with the word, we have a split point. There's lots of ways to do this. You can just use simple indexing, but I'm going to use a little Python trick here called starts with, which actually just checks if a string starts with another string. Another way to do this would just be by indexing. So you would check the length of this word if it's equal to the first index of that phrase, given that length. But this is a little more concise way to do this. And then what I'm going to do, if that phrase starts with that word, also what's nice about using starts with is it's super legible here. You can really read it. It's almost like pseudocode. And then I'm going to append it to that output with word. And then what I'm going to do now is recursively call the split function on the remaining portion of the phrase. So I'm going to return, and this is where my recursive case comes into play. I'm going to say word underscore split. I'm going to input the remaining portion of that phrase, which is phrase, index from the length of that word to everything else. I'm going to pass in the list of words since that's not changing. It's the same constraint there. And then I'm going to input the output. That sounded a little weird, but basically pass the output list that has been appended to. And then finally, I can return the output. So this will happen if no phrase starts with that word. Okay, perfect. So that's it. You can go ahead and run the solutions that are in the solutions notebook here. There's a little more explanation with the comments here, so you can really get an understanding, since it's a bit of a confusing problem and there's lots of ways to do it. And also, as I mentioned, it's kind of a Python-y solution, what I did here, but it's nice and legible. I encourage you to try to basically switch out this phrase using indexing, so it's a little more agnostic as to what language is being used as far as programming languages. But that's it for the examples. Hopefully they were a little challenging, but not too impossible for you to solve. Again, go over them, make sure you fully understand them. And that's it for the recursion homework example problems. After this, you'll be faced with your first real interview questions involving recursion. All right, great job, and I will see you at the next lecture. Thanks, everyone.